Good morning to everyone. My name is Ernesto Sanchez and I am a current PhD student at UNAM, specifically Instituto de Investigaciones en Materiales. And today I would like to present you the following research project entitled Synthesis of Polymer Containing Cyclodextrin Units with Potential Biomedical Application as a Drug Delivery System using frontal polymerization. But first, I would like to introduce what is frontal polymerization. The frontal polymerization is a process to convert a liquid monomer generally into a polymer by a localized polymerization reaction, which is initiated at one strand of the system using a thermal or photochemical stimulus. This stimulus can create a thermal wave that advances frontally, where the initial energy created is the only required energy to initiate and terminate the polymerization processes. On the other hand, beta-cyclodextrin belongs to the family of the cyclic oligosaccharides, which is biocompatible and approved to be used as a excipient. Structurally, it contains 7 glucose units and, due to its three-dimensional conformation, may be able to form inclusion complexes, modifying the physical, chemical, and biological property of the host molecule. So, we can use beta-cyclodextrin and we can also modify the primary hydroxyl phase of beta-cyclodextrin, and using click chemistry we can selectively change the hydroxyl group in the 5th position in the beta-cyclodextrin. So, combining all of these properties between acrylates, monomer, beta-cyclodextrin units, we can obtain new material as a new drug carrier or drug delivery system. So the experimental session number 1 presents you monomer synthesis and intermediate using classical organic reaction as the Williams esterification, nucleophilic substitution, and Stegli esterification. And we can also observe what is the principal yield of this kind of reaction that we made at the lab. The second step, or the second part of the experimental session, tried or aims to modify the primary phase of cyclodextrin, and finally, using click chemistry condition, we can obtain the principal acrylate monomer to polymerize via frontal polymerization technique. Finally, the last step allows us to obtain the new biomaterial using frontal polymerization. And these new compounds will be used as the new biomedical devices or as a new drug delivery system. The previous results are showing the following slide. IR and MNR spectra prove that we have synthesized successfully the compound number 1 and the following spectra for the synthesis path of compound 2, where we can see every proton signal. Last spectra show us how we can obtain the compound number 2, starting from modifying the ethylene glycol, and then in red line the desired compound number 2. To conclude, we report the synthesis of intermediate with a good yield between 55 and 85% via classical organic reaction. These intermediates will be useful to obtain acrylic monomer with cyclodextrin unit, and we will synthesize new polymer with potential biomedical application as a drug delivery system using frontal polymerization.